Okay, we want to solve this differential equation, and we're going to use the exact method. So for the exact method, this is our standard form that we want it in. Like that. So first, we want to factor this y out and then move all the terms over so it equals 0. So when we first factor it out, we're going to have y squared plus sine xy, and then we're going to subtract the y squared, and then we're going to subtract the sine xy. So then we have negative and then I'm just going to factor out this negative y from this term just to make it cleaner. And then there we have it in the standard form where we can identify the m and the n. This being the m, and then this being the n. And first we want to verify that m derived in terms of y equals m derived in terms of x. So when we derive the m in terms of y, we get, and then for the n, when we do the same thing in terms of x, we get that. So they do equal each other, so we can move on. Next, what we want to do is find the integral of m in terms of x. So we're gonna go, here's our m right here. And what I just did was I factored out the negative from the integral. You see that? I have this, and I'm factoring out the negative, so y squared plus sine xy. And then what I want to do is I want to split the integral. Because I'm deriving in terms of x, you can treat the y like an constant, so we're just going to bring it outside the integral, and then just the integral of 1 dx plus, you can treat y like a constant, so you can bring it outside, sine x dx. So then from there, you get y squared x plus y negative cosine x plus g of y, and then I'm just going to factor this negative sign, or distribute, sorry, the negative sign. So we have plus cosine, and just it turns into a plus because it's a negative y cosine x, so turning into a plus cosine x plus g of y. Okay, so then we but just highlight this because this is kind of important. Next, we are going to take the derivative of what we just found in terms of y. So we took the derivative of it in terms of y. So then what you want to do is take this and set it equal to your n, so what you found up here. So what you're going to do is you're going to do what you just did. And set it equal to the n right up here. And then from there, what you want to do is solve for g prime. So then when you solve for g prime, this 2yx cancels as well as the negative cosine x. So you're left with g prime y equaling 1 over 1 plus y squared. And then what you want to do is find the g by itself. So you're going to take the integral, so then it's g of y equals tan inverse of y, and this is your identity, right? So then from there, you want to take this, what you found earlier, sorry, I made a mistake right here. This should be an x, sorry. Cosine x plus tan negative 1y, which is what we just found. Because if you look at this equation right up here, it's what we found plus g of y. And we just solved for the g of y, so we can plug that right back in there. And what you want to do is set that equal to c. And then initially, you can see that they gave us the condition when, so you just want to plug that in. So when you plug the y's, all the y's as 1 and all the x's as 0, you get 0 plus 1 plus pi over 4 equals c. So then we can fill in that c with your final answer, negative y squared x plus y cosine x plus tan inverse of y equals 1 plus pi over 4. And there is the answer.